Welcome everyone to Driving Business Innovation, the latest generative AI advancements, and featuring a success story from Hannah from Workspace Group that's joining us today. So we're very excited about that. Happy you're able to join us. So we'll start off here introducing our presenters. I will pass things over to Chris to introduce himself.
All right. Hello, everyone. If you've been on any of the AI webinars in the past, you've probably seen me before. So I'll give a quick introduction. My name's Chris. I'm the team lead for the customer solutions team here at Safe Software. Dmitri, I'll hand it off to you.
So I'm scenario creation analyst at Safe, and I play with all the cool scenarios and new functionality added to FME.
Hi everyone, I'm Hannah, and I'm marketing manager at Workspace.
And I'm Oliver Morris, business director in the UK for Avinion Tensing.
Excellent. And I'll also note that we have our colleague Natalie on the back end here today. So if you do have any questions at all that come in as content's presented, please do feel free to get those questions into the questions tab, and we'll have some time at the end to answer any questions. Yeah, so as I just noted, under the questions tab there on the bottom right, you can drop those. And keep letting us know where you're tuning in from in the chat on the bottom right as well. Share your emoji reactions with us during the webinar. I've already seen some come in, that's great. And then lastly, I'll just note, if you do have any audio or video issues, you can click the help button on the bottom left for 4 simple steps. All right, and with that, I will have our presenters turn off their webcams just to save on some bandwidth for the remainder of the webinar here. And I will pass it over to Chris to go through our agenda here.
All right, thank you, Elizabeth. All right, so we'll just have a little bit of an introduction before handing things over to Oliver and Hannah to talk about the Workspace Group and their AI use case. We'll then follow that up by having Dmitri talk through some locally run LLM and embedding testings, and then we'll close off with the Google Gemini connector updates and the exciting capabilities that we have there now. As with all other webinars, we will of course leave you off with resources and next steps. So all of the resources that you'll have in terms of learning resources on the FME community. So we'll get to that at the end. We'll also wrap up with some Q&A at the very end. We also are recording this session, and you'll have access to the slides at the very end. So if you do miss a section or have to pop away, it will be available after the webinar. And with that in mind, we'll start off with the introduction. So at this point, we'd like to really invite you to harness the transformative powers of AI. Obviously, AI is kind of popping out into all different softwares that you're likely already using in your suite, your toolkit, effectively. And this is no different in the FME experience as well. It is pretty common to have some barriers with relation to AI adoption, whether those are technology-based or IT policy-based. But if you are able to overcome those, FME is a tool that can enable you to build out some more sophisticated AI workflows rather than just using built-in AI tools for your specific AI suite. So there are a lot of abilities with FME to help make sure you're able to leverage either your cloud provider, whether that's Amazon, Google, or Microsoft, to really make sure that you can leverage all the AI tools that are available at your disposal, or even locally generative AI models as well. So you really have the full flexibility of choosing where your model is accessed and deployed and able to feed that into your workflows. So with that in mind, FME is really here to simplify that AI integration portion. Whether you're using FME to feed in data to your models to pre-train that and build it out for a specific use case, or use some of the pre-existing models or the foundation models as they're referred to. We do this in hopes to make it more accessible and cost less and make it a lot less complex for your team to deploy and use for your processes as well. And the way we do that is by leveraging the FME Enterprise Integration Platform, which is one platform consisting of 2 technologies. Starting on the left-hand side, which is primarily where we will be focusing today, is FME Form, and that is the data authoring environment, or the workspace authoring environment, rather, where you develop your workflows. And that will consist of a reader, which is your source, transformer, which is your tool that's going to allow you to transform the data, whether that's things like validation or connecting to your AI services, whether those are locally deployed or available in the cloud. And of course, we have writers as well. And that's the output system that you're trying to write to. So we'll have a great example from Oliver and Hannah talking about the Workspace Group AI use case, and they'll walk you through how they built out their workflow, including their sources and destinations and everything there. That's really the first piece of the FME integration platform. It's followed up by FME Flow, which allows you to automate your workflows. So you publish them once you're satisfied on FME Form, publish those up to FME Flow, which enables you to run them in an automated fashion. Now that can be anything from a basic schedule to when you receive a webhook from a system, that's going to kick off a process that'll run multiple workspaces and keep your data synchronized across all of your platforms. That's just scratching the surface with the automation capabilities on FME Flow. Of course, we also have things like IoT sensor streaming. So if you're working with any IoT workflows and you need real-time data feeds, that is another capability. In addition to FME Flow Workspace apps, which makes workspaces more accessible to end users. So you don't necessarily need to be formally trained in building all of these FME workflows. You can develop a workspace app and share out a URL. So it's as simple as filling out a web form for your end users. So a great way to make FME more accessible to the masses. And with that, I'm going to hand things over to Oliver and Hannah to talk about their description generating using generative AI story.
Cool, thank you, Christian. Let me share my screen. Hopefully you can see that now. Excellent. Yeah, thank you very much as well, especially to Hannah for allowing me to present to you today and to share the story with all of you. And yeah, let's jump in. Hannah, over to you.
Okay, I'll start by giving you a bit of a background on Workspace and what makes us different to our competitors. Oliver, if you wouldn't mind just going to the next slide. So we own all of our buildings. We have over 5 million square foot of office space across more than 70 buildings in London. And we're somewhere between service offices and traditional leases in that we give our customers flexibility to scale up and scale down, but yet they're in their own space. So they can really make their space a home for their business and design it to suit their brand. I'll just show you a brief video that really sums up what we do. So we're home to more than 4,000 small to medium-sized businesses, which are predominantly creative SMEs, but we do have a wide variety of customers. Our core offering is our offices and studios. We also have workshop and light industrial spaces, as well as our bookable meeting rooms. But then we are also really big on community at Workspace. So we host lots of customer events every month. We do lots to support charity. We have event space for customers and externals to host their own events. And sustainability is also a really big focus for us as well, as we're striving to be fully net zero carbon in the coming years. So I'll just give you a little bit more background about my role. I'm the property marketing manager, so I focus on anything that drives acquisition for our spaces. So that includes building signage, designing branded collateral, working on marketing initiatives for new building launches and also our existing spaces too, and then producing assets such as photography and floor plans for our shop window, which of course is our website. And this leads me nicely on to the amazing support we've had from Tensing on various projects, producing and uploading those assets.
So in a little bit of background to this, we're going to talk about a couple of cases or a couple of pieces of work that we did to support the Workspace Group, and these have kind of laid the foundation for the generative AI piece that we'll talk about in a short while. Okay, so firstly is our image migration project. So last year, Workspace upgraded from using SharePoint to store all of our files and photos to a new DAM, so a data asset management system called Binder. And SharePoint was really clunky. It meant all of our photos were in folders within folders within folders. So not very easy to find anything, and we couldn't sync photos to our systems through SharePoint. But Binder has been much more user-friendly. Nothing's in folders anymore. It's all done using a tagging system. So we're able to find everything much more easily. And also because photos are tagged correctly through Binder, they're then searchable by keywords and SEO terms, and they also automatically sync with the back end of our website and our CRM. So the integration is just working much better too. The only problem with the upgrade was the manual process of migrating all of our assets. This meant just downloading everything manually from SharePoint, then uploading it all to Binder and tagging everything as we did it. So things like your name, size, location, building, etc. And there was also a free tagging field where you can highlight specific features of each space. So there's a lot to input. And obviously we began doing this manually. It was just really time consuming, as you can imagine, with nearly 10,000 units, unit photos, sorry. It was going to be such a huge job. So we looked to outsource this, and we found that it would take one person a year to manually upload everything. So yeah, this is where Tenzing came in.
So a little bit of background to this, we built a range of workspaces to undertake this kind of migration from SharePoint into Binder. So we used FME form, and inside that the SharePoint Online Connector transformer to read in all of those images. And then we used the HTTP caller and some new functionality that's become available, which enables you to import an OpenAPI spec. So we imported the OpenAPI spec from Binder, and then that enabled us to kind of quickly and easily set up a workflow by which to migrate those images over. As part of that migration, we were taking those folders that Hannah mentioned, extracting and kind of standardizing the unit names, building names, and just general terminology. We also utilized a couple of third-party tools. So we played around with Amazon Recognition, which is kind of the image classification and categorization and object identifying tool. And also another third-party tool that's very similar, ironically, called Similar. And it basically tags components or objects within images. And so we use that to effectively identify different components within these unit spaces, particularly things like if there's a window in the picture, what type of floor it is, if there's furniture, those types of things. And that was kind of the first steps, I guess, towards us using machine learning techniques to undertake the tagging of materials and workspace data sets.
Yeah, we're already really seeing the benefits. It's now really clear for us to see which spaces are missing photos on our website, and therefore we know we need to outsource getting unit photography done. Obviously, our shop window looks so much better as a result, as it's now much fuller. Our inquiries and sales teams have these photos to hand now, obviously, to better sell the space when speaking to prospective customers. And also the photos are now filtering through to our marketing outputs properly. For example, this Workspace recommends email. This is an email we send following an inquiry to suggest units for prospective customers to go and view based on their requirements. And this pulls unit photos through from our CRM. So obviously where photos were missing, this wasn't populating our email marketing well. So it just didn't work as well as it should have. So next is our floor plan project. This is the next thing we worked on with Tenzing. So floor plans were a really difficult ongoing project for us, and there was just no easy solution. We've tried various different methods over the course of more than 3 years. Historically, being an old school property company, we initially only had hard to read architect's plans in lots of different file formats. Also over the years, developments of spaces and building works have meant that buildings have changed, and everything was just really disjointed and all over the place. And the plans were just obviously not something we wanted to be handing out to customers. So we initially began using Matterport, which was really great technology, but the way they worked just didn't quite work for Workspace. They had to scan whole floors continuously. And because obviously we've got customers in spaces, it meant gaining access to all those spaces in sequence. And as you can see in this image, this gave us whole floor plans rather than individual units. And there's loads of units missing here as we couldn't gain access. Also, the cost was fairly high of doing this, so we had to prioritise getting individual empty units done as they came back to us. So of course units were totally sporadic and we absolutely couldn't get them done in a sequence, meaning they all had to be done on different models, again making it really expensive. So then we moved on to getting them hand drawn by designers using the original architect's plans, and then going and hand measuring the units. And it was whilst doing this that, having worked with Tensing on the image migration, we discovered that they were able to help us with the floor plans too.
So for the floor plan creation, we were taking these kind of original DWG and in many cases as well PDFs, and effectively utilizing FME to strip apart the most useful components for these unit areas, and then getting some of the team to help to build out effectively these defined unit spaces thereafter. The generation of these floor plans for the individual units that you can see in the bottom right, they also pull in information from Google Sheets dataset, which covers kind of the standard floor name, but also the capacity of the room in terms of people, and also the space and the address of the property. So yeah, it was all an undertaking within FME to do those kind of file conversions, and then also pull from other data sources. And yeah, at the moment we kind of created about 800 units or so in the past month using this technique.
Perfect. So where we're at now, we're supplying Tensing with DWG or PDF plans for the whole buildings, for the whole building at once, and that's meant that we can get all units for that building in one go for a fraction of the cost, rather than having to do units just as they came back to us. We've got 18 buildings complete, which is amazing, and we've got a rollout plan now for the rest over the summer. Floor plans are being used to send to prospective customers, and also to customers waiting to move in, so they can space plan and buy their furniture and everything ready for their move in. And now we're just building the functionality in our website as well to upload them on each unit page. So they'll be displayed for all units, just like you'd expect to find on Rightmove, for example.
Okay, so now on to the actual generative AI challenge, as it were. Now you've kind of understood the foundational sources, and hopefully shortly you'll understand why we've gone into a little bit of detail as to the importance of those. So goals, blocks, keys, and results. The goal has been to generate unit descriptions for the thousands of units that Workspace office lets have available across all of their buildings. The blockers were, of course, that the data is quite diverse in terms of file formats and also where it is located, be it inside this new binder catalog or within a MS Dynamics CRM or Google Sheets, for example. The key here has been that for us, FME has been invaluable to go and reach out to all of those different data sources, but also it is a fantastic orchestration tool for tying in and making calls to these third-party AI services. So we'll go on to talk about the use of Anthropic and OpenAI in this workflow. And the result has been that we've been able to, as part of the proof of concept, has been that we've been able to generate over 100 unit descriptions so far. And it's really started a kind of phase of iteration to get even better and improved unit descriptions before we progress further.
So the image here is a screenshot of one of our unit pages, and this shows the generic default copy we have on most of our unit pages. We've occasionally had more detailed descriptions written by a copywriter or one of our team if a building's struggling and the occupancy is low and we need to give it a boost, or if a particular unit needs a push. But obviously with around 5,000 units, collating all this information from centre teams and writing them all up manually has been a large task that we've never really got round to. So that just means there's no extra detail around amenities, specifications and views, etc., that you'd expect to find, when taking a space. Some of those qualities are obviously really essential in selling the space too, such as natural light, air conditioning, flooring type, etc. People want to obviously read more about those. And there's some things like views from the window, for example, that you of course would never know just from seeing the image. So it's this valuable additional info that we're starting to gather from our centre teams now, so that we can supply it to Tensing and get FME to write this up.
So this is where we get to the kind of multimodal nature of these inputs that we have. So we have the unit floor plans that we've generated, and out of those PDFs, we created PNGs, basically. The range of photos for those units, and in many cases, they're more than just one space, right? They could have, I don't know, kitchen areas or kind of breakout meeting room spaces. And also there's a range of additional text. So for example, within the CRM system, there's a kind of notes description for individual units that are used by the building's office managers to kind of populate positive and negative aspects to the unit. And actually one of the kind of neat components of trying to kind of pass all of this information to a generative AI tool is to kind of pull out selectively the positive comments from that type of input. We've also got the addresses of the areas, and just more broadly the kind of characteristics of the building that go that can be used inside the descriptions, as well as of course the local area in London, which is the building is situated. So I've kind of mentioned the different data sources that we've got. I don't need to go over that again, but on the FME side, readers, of course, HTTP caller plays a massive role, both calling data from Binder, but then also making calls to the different AI services we use. As I mentioned, we have a PDF reader to then write out to the floor plans to PNG. We're pulling data from Google Sheets. And although in the demo just about to give, it doesn't show the OpenAIVisionConnector or the AnthropicVisionConnector, they are there in spirit, because I've basically taken the kind of key components out of those transformers that are available on the FME Hub to kind of show you a little bit more detail as to what's going on behind the scenes. So now is an opportunity to give you a bit of a demo. Let me try this. I know you can't see this at the moment. I will zoom in very shortly, but briefly, I wanted to kind of give you an initial overview of the kind of data sets that we're loading in. So this first part of the component, I'm not going to be particularly dwelling on that much, is pulling data from the Binder DAM system. So this is basically just lots of API calls to pull down the imagery associated with the units, and then I'm just simply filtering down by an individual building. The next sections are effectively pulling data from Google Sheets. So this is pulling some of the data that we've extracted from the CRM for now, which has got all of those kind of individual unit descriptions, and also pulling from another Google Sheet which talks about the capacity of the room and the floor space. But let me zoom in a little bit now, because what I'm effectively doing is joining all of this together to produce a range of data that is obviously not just text-based, but image-based as well. And there is effectively a process to obviously, there's a need to encode that imagery into base 64 to pass it up to the Anthropic and OpenAI services. So let me just kind of give you an indication here as to what's going on. So once all that data is kind of available to be passed to the services, the most important thing to get right is the prompting. So this is effectively what you're passing to the generative AI service, and it gives you an idea of how you can kind of orchestrate the whole process. So the way that we found it to work the best is to kind of give a little bit of I guess a heads up to say, you are acting as a copywriter, you're super talented, experienced person. You're working for a UK company, therefore we expect you to write back in British English. And we're going to give you some images from an area, a floor plan perhaps, and also some descriptions. And then following that, we've kind of provided a range of different examples. So this is to try to make sure that those generative AI models kind of follow the tone of voice that we're after. So these are taken from descriptions that have already been done by a copywriter. And then we're into kind of the input section. So here we are building up the images and providing the unit name, the building which it's in, and some additional kind of floor space information. And then past that, basically, we're looking at those internal notes. So here I've said, okay, well, you're going to be getting some internal notes, but only take the positives. If somebody's written this is a really dark and dreary unit, then hopefully this tool will have excluded it. Actually, turns out it does quite a good job of that. And then more broadly, there is a kind of building description. So telling you that there's a cafe in the area, meeting rooms and shower facilities, as well as the kind of area that it's located in. And importantly as well, suggesting that it shouldn't get a little bit, it shouldn't start to hallucinate, or try to encourage it not to hallucinate that much by basically saying only base your descriptions on the images and the text inputs provided. Please don't start going crazy and creating brand new ideas about this space. And so what we do is we basically end up passing it to the Anthropic and OpenAI services through HTTP callers. Now, one thing that's quite interesting with this is that when we first tested this, we thought that it would run through quite quickly, but actually it can be a little bit temperamental. So this is where some of the latest functionality in the HTTP caller came in. So enabling retries and also kind of staggering the requests, because depending on your subscription that you have with these different tools, you get different kind of request limit or limitations. So this is really nice because it enables you to kind of pace out the calls and requests. And then finally, once you get a response from these tools or from these API services, we clean it up and end up with effectively a internal comment, an Anthropic response, and also an OpenAI response, which hopefully, if I switch back to the presentation, we can bring up. There we go. So I don't need the video, and move on to the results. So the first 4 columns here are just more broadly about the unit itself. The second or the final 2 columns are the response that we get back from Anthropic and from OpenAI. And it's quite interesting to compare how they differ, but also look at some of the words that they have used that are more similar. So what's really interesting is, I think in some of the text that it's used as a reference, nestled, the word nestled is used, and therefore it's kind of weighted that word more in the OpenAI response in particular. So I think one of the ways that we can enhance the prompt going forward is to feed it the prior response, so that it doesn't repeat any of the adjectives that it's used in previous comments, and to stop them being, I guess, a little bit repetitive, shall we say. But in summary, as a kind of first go, it's done really impressively well, and from the checks that we've done, it really hasn't hallucinated at all. And so I think what we've shown is that FME has been really good at pulling in those kind of different formats or multimodal formats and pulling them all together, and then acting as a super tool for orchestrating out to these different AI services. It's really important to get the prompts working perfectly, and this is just a general iterative and learning process until we get it right, and we make sure that that tone of voice is exactly what Hannah expects, basically. And I think it's also really nice to be able to use a range of different AI services. They really are quite cheap to run, and therefore it means that you can basically pull in different models and different services as they come out and see what types of responses you get back from them.
Yeah, and the benefits really have just been invaluable. With all of these projects, the big struggle really was just the sheer quantity of units and assets we had, which required so much admin time and resource to produce and upload. So like with unit photos, it's taken away a year's worth of manual labour and turned it around in just a few weeks, which not only has saved us so much time, but it just means everything's already functioning so much better. Floor plans just seemed an impossible task, and they were going to be a huge part of my role for what seemed like forevermore. But we've now solved this issue in a matter of months. And finally, unit descriptions. The prospect of getting all of these descriptions written up in 1 week is incredible, and will massively help our customers and our teams to sell the spaces.
Just finally, a few next steps. What we would like to do is, instead of writing out to Google Sheets, to put these outputs directly into MS Dynamics. And basically, once there's a couple of extra fields available in there, we can basically send that data up from FME directly. And then that will mean that the office managers and Hannah and the team will be able to kind of send that information directly onto their website and make a much more streamlined process to do that publishing itself. The other thing that we are kind of excited to play around with is looking at further details that we can get from the building CADs themselves. So, for example, either taking the center points of the units or the doors and finding how far they are from T-points or breakout areas, or perhaps some meeting rooms, so that can further improve the descriptions for those particular units. And finally, with regards to building area descriptions, of course, these large language models have digested an awful lot of information about, well, lots of locations all around the world. In fact, they're really very good tools for planning holidays and stuff. But with regards to buildings, if you're explaining to the model where that building is situated, it will be able to construct a really nice description as to what the surroundings are. And so we're looking to be able to support further descriptions like the one that you see in the bottom right to better describe the building office location. Cool. And with that, I think we're at the end, so I can hand over to Dmitri.
Okay, so let me share my screen. So the goal of my part is to show you maybe a very, very simplified version of what Hannah and Oliver just showed. This scenario, actually, so that was Oliver's idea. I tried it back in January. I really loved the results. And I will show you the workspaces, which then we will give to you, and you can build your own workspaces based on those examples. So imagine we would like to create a database of metadata for images, something like, you know, a description, a set of tags, a creative title. We have a few blocks. We may have thousands of images, and our photos may be sensitive. We don't want to send them to ChatGPT, for example. The answer is to use a locally run LLM, and we can have a look how it all works. So what is Ollama? Ollama is a tool that allows you to run those large language models. You may hear on the news that, for example, Meta released a new language model. Okay, so what I can do with that? So you can download Ollama, just, you know, basically click on that, go there, download, install, and you have an instrument to run a language model. Then you just simply run it like that, just type Ollama run and the model name, and you're good to go. Now you can ask questions. For example, here I ask, do you know what FME by Safe Software is? So, and get a pretty good answer. And it also runs a server. You can see here this icon on my screen. It means that you can run a transformer, for example, that talks to a local server and runs queries against the locally run model. So how I approached this process. So I had that locally run language models. I asked ChatGPT for some information which has non-sensitive nature, things for visualization, HTML, CSS, JavaScript. So, and I did that, well, most of that I did through FMU, of course. So here is a simple workspace, which you will get. Later we will send that out. I asked ChatGPT to suggest a database structure for all the metadata, and even write for me SQL statements, which I then just run and created a database. Then inside the workspace, I read a whole folder of just path names of images, and I actually will switch to the workspace. Yeah, this one. So I read these images here, not the images, just their path. And here I ask to describe me a photo, and I use a multimodal model. That it means that it can not only work with text, but it can also process images and get lots of descriptions for the images. And then I ask to create a set of tags for me for each image and a title. Then, I use this transformer just to extract EXIF information about latitude and longitude and put everything into a database in this section. I normalize all the data, so I have not just a single table for everything. I have 3 tables: a table for images, a table for tags, and a table for that combines images and tags. Here is my, So then after that, I need to read that database into visualization of workflow, into HTML. So I created another workspace that reads all those tables, brings them together, and generates a JSON file, which then I can visualize. So all that HTML, CSS, and JavaScript was generated for me with ChatGPT, and all the changes I have to make was this line. So I basically said where my JSON is. If that would be deployed in a FME Flow environment, it could be just a URL, your webhook, to the same workspace that generates that JSON on the fly. So that means that you can have a live database where you make your updates, and you will always get the very up-to-date information with that. So, and that's what I got. I sent like 50 images from my archive, and here's the results. So I have my tags here, I have my images here, and I can select a tag and get something with that. So something like this. Can you see the problem here? I've got tons of tags. That makes the whole thing not very usable, because I cannot realistically get anything rather than one image. That's not very helpful. So I had to go back and redesign my workflow to work a little bit differently. So basically, the same workspace, but doing it a little bit differently. So first, I generate all the descriptions. Then I give a single description to LLM and get back all the possible tags, remove all the duplicates, and after that, again, I just save everything to a database. And we can check the results of this revised approach. So instead of generating tags independently, I generate all the tags within a single run. And that gives me a lot more realistic, manageable, or reasonable set of tags. You can see them on the left. So for example, I select landscape here, or equipment, for example, and that all makes sense. So, but what if we have 20,000 photos? We cannot just create a single description, send it to a LLM. Even they have huge amount of tokens now that you can send the amount of information. Apparently, it's not that much when I recalculated that on the text input. So the answer is we can try embeddings. Embeddings are basically, it's a way of turning our words into tokens and tokens into numbers, which we can, and machines understand numbers. So then we can run comparison of those numbers against the models and get some answers. So to me, it was really complicated. I'm not a programmer, I'm a cartographer, and I need something really, something that I can see, I can try, and I can make sure that it all works. So the tutorial I tried was using llamas as an example of embedding. So they took some facts about llamas and put into a model and then started asking questions. But that wasn't convincing because I think any model should know about llamas something. So I came up with this fictional animal, tiger rat, living in a post-apocalyptic world. I asked ChatGPT to create 25 facts about it for me. And then I started asking questions about that, and the answers were quite reasonable. So you can see a very simple workspace here. I can actually show that workspace. Yeah, this one. Here are my facts. And all the magic is happening inside Python Color. So unfortunately, we don't have, at this moment, it's so new, so fresh, so we don't even have any standard transformer for that. So everything is happening in Python Color, where we embed those those facts, we embed our question, and then run that question against those facts and get some answers back. So I tried to, well, something more realistic. I tried embedding some transformer descriptions into a language model and run some questions against that. So you will get this workspace as well. You can try that. I took all the transformers from starting with numbers up to D. Here is my workspace, not this one, this one. Yes, and we can ask a question, so we can run this demo. So here I have my text file. I can show you how it looks like with all the transformer descriptions here. I turned them into a JSON, so don't be scared. So all this part is just creating a JSON. So you can feed it just a simple text file. And then we run it again in Python Color, and then we generate a report. So we can try running this and ask some question, maybe, what can we do with arcs? And you can see I don't even mention FME here. It means that the model understands it should work with my data and return results based on whatever I fed to it. Oh, what's going on? Let me run it again. I'm not sure what's going on. Well, we actually can have a look at the answer anyway, because it was generated here. Quite a few transformers are suggested, and you can see the answers are turned with the large language model into a reasonable human-readable response. So arc stroker, arc property extractor, arc estimator. So everything what we get from A to D in the transformer descriptions. So, and then I tried something else. Here's just another example where I ask, when I don't even know what a transformer to clip or cut features, because, for example, I'm new to FME, so I asked this question and got a reasonable result. I tried then to embed Revit data. So I took just a few types of objects. I took rooms, doors, windows, and sprinklers. extracted that information again, made just a single JSON from it, and embedded into a model, and also send there a few questions. For example, in which room we would organize a meeting for 6 people, or in which room we have most of the sprinklers, and so on. So I run this in Python caller, and then update my Google Sheets with the answers. So I have my questions there, and I update it with the answers. I will switch to this workspace as well. Not this one. Yeah, here it is. So here I just prepare my data, keep just a few attributes. You know that in Revit, all the objects have hundreds of attributes. I keep just a few very basic ones. For rooms, I keep dimensions. For doors and windows, I show or keep the information, which rooms they separate or connect. And for sprinklers, I basically just keep the ID and floor where they are. So, and create a simple JSON looking like this. That's all my data, which I then turn into vectors, embed into LLM or embedding model. And then I pass all the questions. So we also can have a look at the questions, which I aggregate just to have a single feature. Here, all the questions that I have. So because I have a single feature, it means that I will have just a single Python call instead of running it as many questions as I have, as many times as many questions I have. So I will run it just once, and then I will get all the answers, and then populate my database with the answers. And also here I keep just a single question for some visualization, just as an example. So the question was, which room might have dangerous equipment or hazardous materials? And here is the answer. So it lists me all the rooms that may have some dangerous equipment. And here in my prompt, I specifically asked for giving me a list of IDs of those rooms. So for me, it's easy to extract this information. Basically, I run a search and get those numbers, and then can merge them with the geometries and highlight. So I can run this part. And show it in 3D. Here they are. Those dangerous room with dangerous equipment. And the last thing I will show you, just the table of Google Sheets updated with this information. So here it is. All my questions and all the results. And they're not perfect, but in most cases, they're quite good. For example, I can ask, are there any internal windows? The windows that separate room and room, not the room and the site. So and I get all the internal windows, for example, and so on. Or list all the sprinklers in room, this one. So, and we get the answer, which again, easy to process, extract, and visualize. So this is it. So you will get all these workspaces. You can play with them. And with that, I pass the presentation to Chris.
All right, thank you, Dmitri. Okay, so I'll take us home with the remaining bits on the Google Gemini connector, and then we'll go over some resources. So we'll just start off by introducing the Google Vertex Model Garden. And so this is essentially the backend where you configure which models you want to deploy and have access to via their APIs. So right now we have it configured with their Google Gemini 1.5 Pro model. That is their latest AI model that is up to date, and it auto updates to the latest version. So there's no need to kind of update to the specific date build versions that are released. It's a pretty simple transformer to use, just like all of the other AI transformers that we have, or any other transformers in the FE platform for that matter. So this would be the Google Gemini connector parameters on the right-hand side. It's configured using an OAuth authentication method. It integrates with the REST API, just using those HTTP callers that Oliver was showing earlier. And yeah, in this case, we're working specifically with their language Gemini model, but there's also access to their vision model using the Imagine engine and speech using universal speech model. So we'll go through a quick demo at this point, just talking to how to access it. So it starts on the FME hub. You can also download this directly from FME using the quick add menu, and it requires FME 2024. As I was just mentioning, there are a couple of required parameters, and the OAuth web connection is part of that. We also provide that to you on the FME hub, so you can download that from the link there. And aside from that, it's just entering some basic information like the project ID, so Google knows which account to bill it to, and the region in which you want to run the model from. So that would be a quick example of actually downloading it using the quick add menu. In this case, I have the Google AI Web OAuth connection pre-configured, and I have a publish parameter for the prompt and project ID that I want to use for those parameters. In this case, I'm just sending a basic hello world example, so we'll see what it provides us back with. Inside of this custom transformer, we have broken down the JSON, so it actually exposes it as an attribute called response for you. So you don't actually have to do any JSON fragmenting or flattening or anything. It just comes back to you in plain text, so it's easy to use in the rest of your workflow. Okay, so that is a very quick example of actually using the Google Gemini connector. And that rounds us off with the three main service providers, cloud-based service providers for AI, and that would be OpenAI in addition to the Azure OpenAI. Both are accessed through the OpenAI ChatGPT connector, in addition to all of the other OpenAI connectors that are available on the hub as well. There's also the Amazon Bedrock connector. So if you're an Amazon organization, you do have access to the Bedrock connector to interact with your models that are available on there. And again, you kind of pick what foundation model you want to access and then run with it. And then, of course, now we have the Google Gemini connector, which enables you to interact with the Gemini 1.5 Pro model, but also have access, again, to all of those foundation models in the model garden, which I believe there's about 165 models at this point. Now, one of the neat things with the model garden, I'm just going to go to full screen for this, is that as you go through the model garden, you'll actually notice that there are a number of the pre-built foundation models. Again, the default one for the Google Gemini connector we're using is Gemini 1.5 Pro, but there's also the option to deploy from Hugging Face at the top of the model garden. So we'll see my cursor goes up to the top there, and it opens up the side menu, which you can launch directly into Hugging Face. So in addition to the 165 models that are available on Google's model garden, you also have access to the 700,000 models on Hugging Face, and they're very easy to configure and deploy on your Google Vertex endpoint. So simply just going to the deploy dropdown, clicking on Google Cloud, and it'll pre-fill the entire side panel for you there. At this point, you can change the name, change the embedding, the endpoint rather, and any other specifics about the model that you wish to customize here. So if you want to change the region as well, you can do so. And at that point, it kind of starts to configure in the backend from the Google Vertex perspective, and it gives you a sample response here. So I'll give you an example of how we can use this in FME, and that would be using the HTTP caller transformer. So it's very simple to configure, just like Oliver was showing in his workspace. The HTTP caller is extremely powerful, as you simply just fill out some basic information like the request URL, the HTTP method, in addition to the web connection you're going to authenticate with. And then it's as simple as inserting the upload body, and in this case, we have a sample response, which I have taken a look at and configured some attributes so I can kind of feed that into my workflow. So this makes it extremely reusable in a workspace that you could, again, push to FME Flow for automation purposes, whether that's in an FME Flow automation or a workspace app. And this really enables you to let the data dictate what's happening in the workspace and be an AI-driven workflow, essentially. So that's a little bit of a brief introduction to the back end of the Google Vertex AI platform and how you can have access to deploy over 700,000 models using Hugging Face. So really they extend their model base by integrating directly with Hugging Face. And it's very easy to interact with those because you can reuse the Google Vertex, the Google Vertex web connection on the FME Hub with that HTTP caller transformer. So it's just easier to integrate and access those models using that connection, because you can reuse it instead of having to build your own. And with that, we're into the resources section. So we'll just touch on all of the resources that we have here available to you at SAFE to help you on your FME journey, whether that is AI driven or otherwise. So of course, we have an ebook that is the spatial data for the enterprise ebook. It's kind of a getting started guide that you can follow along with. It has a couple of great examples in it. There's also free training available on the FME Academy, and that is a module-based learning platform that allows you to choose your own learning path and kind of follow along specific examples with templated workspace and guides you on your journey there. The knowledge base is for tutorials and articles that help you follow on for specific examples, and they typically come with example workspaces as well and give you step-by-step instructions on how to approach specific data challenges. Of course, you're familiar with webinars because you're at this point already. We, of course, record all webinars, so do feel free to take a look at safe.com/webinars and see all of our previous recordings in addition to what's coming up in the near future. And take a look at our podcasts as they're on demand. So we're actually going to be a guest speaker on EM361, and I believe this was recorded as well. So yeah, you can take a look at that, and they will be linked in the slides, which you can download from here or get after the fact. And yeah, in terms of next steps, obviously feel free to get in contact with us. We'd love to help you get started with just sending a simple message to info@safe.com, or get hands-on with the FME platform if you haven't done so already by experiencing the FME Accelerator. It's a free 90-minute workshop that allows you to really test out the FME platform and see its full potential before committing to purchasing any licenses. There's no credit cards required or anything like that. You simply just get a virtual machine that allows you to test out the platform, see what the capabilities are, and if it's a good fit for your business, and then move forward from there. And Elizabeth, I'll let you speak to the community badge slide.
Yeah, awesome. Thanks, Chris. So as a thank you for joining us today, we have a community badge code to share out. If you're a member of our community, I just dropped it in the chat there. If you aren't yet a member of the community, definitely check it out. It's a great place to network with other users alike, as well as FME experts, and yeah, get answers to your questions, find resources from there as well. And then next here, we do have our Q&A portion. So I'll just kick things off by saying we may be going a few minutes over time today with Q&A. We're gonna pick out a few questions here to address. I'll get our presenters to turn back on their webcams now, actually. And we can take a look through the questions panel here today. But if you aren't able to stay a few minutes over time, no worries. Thank you so much for joining us here today, everyone. We really appreciate your time. Awesome. And we had a ton of great questions come in actually today. So I'll give our speakers a moment. They can start, browsing through the questions, and maybe we can pick out a couple to start off with here. I'll also invite Natalie on stage if she'd like to join. She's helping us on the back end with Q&A. Thank you, Natalie.
I really like the idea of creating some voiceover advertisements. So the whole text-to-speech tooling is really neat. I don't know what you think about that, Hannah, or how you could incorporate it, but that would be pretty cool, because the natural language and speech that you get back from these tools is actually quite impressive. We just need a nice few different London accents, and we should be good there.
That's really cool.
Yeah, right. Yeah, there was one from Ian about kind of the outputs that you can get back in terms of whether they're structured or not. So one of the features that we built within the Ollama is that there's a particular property tick box to have it as a JSON structured output. You have to be careful with which models you use, because some don't respect that request. But the most recent ones, like Llama 3 that Dmitri was talking about, and also the Microsoft one, Phi 3, they seem to respect JSON pretty good. And we've had some good structured output from those.
Yeah, just to elaborate on that as well too, it is fun with those models is with your prompt, you can actually provide an example of a example format that you want back. So whether that's a specific JSON structure, or perhaps you wanted to give back XML or CSV specific structure, you can ask it to give that. The response will typically come back as JSON, and in a field, you'll kind of have the piece that you have asked your formatting specific for. It'll kind of match that template for you. So yeah, there's a lot of awesome capabilities, and it allows you to help with your downstream operations depending on what you need the response to come back as.
Yeah, but still put a few checks because, yeah, just some string replacers just to get rid of whatever is not related. For example, if you ask for Python, it sometimes will return in Python. Sometimes it will prefix it with tick 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 Python and then end it with tick 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 Python. So you would like to to get rid of that before you pass that Python to Python coder, for example.
There's one kind of question here, Hannah, about how people find office space based on like geographic location. How do we do that at the moment? Yeah.
I don't honestly know. I can ask our digital team and come back to you on that.
Yeah. Oh, with regards to costs, I just did a kind of quick check, and for the kind of 9 or so requests as I did just in that dummy example that I showed on screen, that cost like 15 cents to run. So if you scale that up for kind of 8,000 or so units, and then you multiply it by 2 from the 2 different service providers, you're talking at about $600 to $700 to do those types of requests. So that's why the prompting is so important, basically. But also, I don't think we necessarily need to create new unit descriptions all the time. But what we can do is, as new units become available, we can basically prompt to generate effectively an updated unit description, right? So it actually turns out to be, well, compared to having somebody manually write that copy, it's actually a really cheap process. And I think it's only going to get cheaper as well, right? Because the latest GPT-4 model, the 4.0, I think that's half the price of the original GPT-4, right? So the costs on these types of things are coming down quite quickly. I think on the, well, I don't know. I mean, that's a really good point on the internal or indoor navigation, because you do have like Matterport, right, Hannah, for some of your sites. So there's maybe we can do something with that as well to potentially add more descriptions or give the models more content as well.
Yeah, we can. We only we sort of tried the first 10 buildings using Matterport, so we'll have those. But yeah, we can definitely use those to write some more descriptions. Yeah, and you'll probably be able to move around so much that you can see out of windows and things, so that you can see views and extra information like that.
Yeah, very cool.
Awesome. Any other questions that we want to get to this morning that any of our presenters see there?
There was just one quick one from Kemal here. I'll pop that in. And it was just asking, or they were just asking why building description was hard-coded in the prompt.
Yeah, that's a simple one. For the proof of concept, we just did it on one building. So I was lazy, or we were lazy, and we basically just included it for that particular building. But as we look to do it for other buildings, then of course that will be just another variable that comes in going forwards. Yeah, so good spot there.
Awesome. I think we've wrapped up all of our questions at this point. Just final call out to the team in case I'm missing anything else we want to address here. Oh, it does look like a new question just came in. I'll pop that on the screen in case that's one we can address live or we might need to follow up on.
Yeah, I don't know how to answer that one at the moment. Yeah, I'll have to get back to you on that one.
Perfect. All right. Yeah, so our safe team will stay online just for a minute or two longer, just in case anyone does have any more questions they want to pop in the questions tab. We'll try to get to those in the back end. And I believe we have a couple we'll follow up with via email as well. So thank you so much, everyone, for your questions here today. and joining us. And then huge shout out to our full team of presenters, especially Oliver and Hannah, for your time today. We really appreciate it. All your time preparing content and sharing your success story with us today. Thanks so much, everyone. And if you do have a brief moment to fill out our webinar survey, we appreciate any feedback. I just dropped that in the chat a few minutes ago. Hope you all have a great rest of your day. Bye for now.
Bye-bye. Thanks.
Thanks, everyone.
Bye, everyone. Thanks.